All right, so 5.6. I'm going to spend a couple days graphing. So graphing inequalities. So it's just graphing a line. So the way that the graph will end up looking is, we could have like a solid line like that, and then we're going to have like an answer, like it'll be, saying like all this is an answer. So that's how like the graphs will look. But I show you that at the beginning to say that you're going to have some questions at the beginning of the problems that say tell whether the ordered pair is a solution. So just like at the beginning of the chapter, if it's a solution, is it a solution means plug it in and see if it works. So we've done that a bunch. You know how to plug stuff in. So on the graph, if it says, is it a solution? Well, any point down here, that's a solution, that's a solution, that's a solution, that's a solution. Anything down here in the shaded part, all those are solutions. And here's something that I'll talk about more in a minute. If it's a solid line, on the line is also a solution. If it's a dotted line, it's not a solution. So I'm going to come back to the dotted line part in a minute. Okay, and then anything over here is not a solution. So all these down here are solutions, and anything up on top is not a solution. So anything in the shaded part is a solution. Okay, so you'll have, is it a solution? Just plug in the points, and then it'll give you a graph and ask, is it a solution? So as long as it's in the shaded part, it's a solution. If it's on a solid line, it's a solution. If it's on a dotted line, it is not a solution. So let's talk about solid and dotted here in just a second. So you'll have some, let's graph x is greater than 1. So it's like x on the x-axis go to 1. Okay, now there's no and equal. It's just greater than. So that means like the line x is 1 is a vertical line going through 1. And it's a dotted line because it's not and equal. If it had this like and equal part underneath it, then it would be a solid line. It's like when we did graphing on a number line, if you colored in the circle, it was an and equal. If you didn't, it was just greater than or just less than. Okay, so where are the x numbers greater than 1? To the right. So all this would get shaded in. Okay, so if we had y is less than or equal to 3, on the y-axis, go to 3. This one is and equal, so when I go sideways through 3, it's a solid line. Okay, and then where are less than would mean under. So all this down here, including any point on the line. Okay, because it's an and equal. Not on this blue one up here. Nothing on the dotted line is a solution. Okay. All right. We're going to have some to graph that will be either a straight horizontal or vertical line, like the blue and the green one. So if it's x is greater than or less than, it's going to be a vertical line. If it's y only, it'll be a horizontal line. Okay, and add, let's say y is greater than 2x minus 3. Okay, so y-intercept is -3. The slope, 2/1. So go up 2 to the right 1. If you want to do it again, go up 2 to the right 1, like you can. Just greater than. It's not and equal. So it's a dotted line. Okay, so then how do you know, because it's on an angle, where's greater than, where's less than? Okay, so what you can always do, this will always work, and then I'll show you like a little shortcut in a minute. Pick any point you want. I'm going to pick 0, 0. And I'm going to plug it in. And if it works, then where 0, 0 is a solution. And if it doesn't work, then the solutions are on the other side of the line. So if I put 0 in 0, 0, that's the easiest one to do, because you get a lot of zeros, and zeros are typically easier to work with. Is 0 greater than -3? Yes. So where 0, 0 is a solution. Not on the line. Okay. So let's say we had and it said graph that one. All right, well, I think it's easier to make this into slope-intercept form. Divide by 2. Y is less than, can't divide that, plus 3. All right, so when we graph it, y-intercept is +3. The slope is -3/2, so go down 3, 1, 2, 3, and over 2. And then this one is a solid line. Okay, so where do I shade? Well, let's plug in 0, 0. And you might think like, oh, there's a fraction. That's okay, because when I plug -3/2 times 0 is just 0. That's why I like doing 0, 0. 0 plus 3 is 3. So is 0 less than, plugging in 0, 0, is 0 less than 3? Yes. So that means I shade where 0, 0 is, because it worked. Okay. So you can always pick a point to plug in and check. Okay, but let me show you something also. This only works if the equation is in slope-intercept form. Okay? Greater than. And I shaded on top of the line. Less than. I shaded on the bottom of the line. That always works if the equation is in slope-intercept form. So I would recommend very highly that you make the equation in slope-intercept form, because then you don't always have to plug in that point. Okay, so there is a way to graph this line without converting it to slope-intercept form, but I think most people like to do that, so we'll just leave it like that. Okay, So you're going to have a group of 5 or 6 questions. I think it's 6. Actually, it's 7. Is the ordered pair a solution? Plug it in. Then there's 6 questions where there's a graph already there, and it just wants to know yes or no, is the point a solution? If it's in the shaded part, it's a solution. If it's on a solid line, it's a solution. If it's on a dotted line, it is not a solution. All right, then you'll have some to do where it's a diagonal line where you have x's and y's. Okay, some of them are set up like the first one I did where it's y slope-intercept form already, and then a couple of them will not be, and so you gotta, I think you should switch them. Okay. So the graphing part is a little bit harder, but the beginning part should be a bit easier. Actually, we're only doing odd questions, so you won't have as many as I thought. Okay? All right. Have a great day, guys. We'll see you tomorrow.